So we have to factor the quadratic here. So we're going to factor that into x plus 2, x minus 2, plus x minus 2 equals 20 over x plus 2. Okay, so we state our restrictions. X is not equal to 2 or negative 2. We want it multiply through by the lowest common denominator. Okay, so the lowest common denominator in this case is going to be x plus 2, x minus 2. And that allows lots of things to cancel here. So we're just going to be left with 5 because the x plus 2 and x minus 2 in the denominator cancel here. This divide cancels with that times, so we're just going to be left with x times x plus 2 equals 20, and the x plus 2's cancels, so we're just going to be left with x minus 2 as our multiplier. Okay, so again, we've stated our restrictions, so we don't have to worry about the restrictions anymore. These denominators, although they don't exist anymore, we still can keep those restrictions up here. So multiplying this through and solving this, we get x squared 5 plus x squared plus 2x equals 20x minus 40. We're going to move all the like terms to the left-hand side, so we end up with subtracting 20 from both sides. We're going to add 40 to both sides. Okay, and then we're looking for two numbers that multiply to 45 and add to negative 18. So the factors of 45 are 15 and 3. So 15 and 3. So we're going to end up with negative 15, negative 3. And so solutions for this equation will be x equals 15, x equals 3, and they do not conflict with our restrictions, so those are valid solutions. Okay? So we'll do the same things here. Now, here we have a bit of a problem that we have embedded denominators. Now, we do have a strategy to get rid of these embedded denominators, but before we cancel those denominators, we have to make sure that we state restrictions. Now, because we have complex fraction here, we're probably going to need to state the restrictions for this embedded denominator and then for the other divide here. So I'm going to first start with this restriction here before I cancel it out. So x is not equal to negative 3. And our strategy to get rid of this times up here and divide up here and divide down here is we're just going to multiply in the top and bottom. And again, because we can balance the ratio, we're not breaking any math rules. We're not just randomly multiplying things, which is always a bad idea. We're going to multiply the top by x plus 3. And the bottom by x plus 3. So we balance the fraction. Okay, we're actually multiplying by 1, so we don't change the value of the fraction. And when we do this, we have to make sure that we distribute this out. So we're going to end up with x squared minus 3x plus 3x. Okay, so those cancel out. Times negative 3 times negative 3 is 9. And the 8x what's left over after these cancel out. On the bottom, we're going to multiply through, so we're going to end up with x squared plus 3x, and then the x plus 3's cancel, so we're just left with minus 6. Okay, and then we have to make sure that we make it equal to 2. So here, looks like this is not factorable because there's no two numbers that multiply to 6 and add to negative 3. So for that denominator, I'm not going to expect you to write this as a irrational restriction. You can just say that x squared plus 3x minus 6 is not equal to 0. Okay, there's actually two irrational restrictions there, but that would be good enough. I won't expect you to state this restriction as an irrational value, but you can just put that into the quadratic formula. That will give you the irrational restriction. Okay, so there it is. I've got rid of the embedded fraction and I stated my restriction before. Now I've stated my restriction for this new fraction. Now I want to solve this. Okay, so I'm going to solve this. I'm just going to multiply through. They can just cross multiply here, but I'm going to multiply through by the denominator. Since that's not factorable, I'm not going to worry about factoring it. Okay, so because that is, if it was factorable, we do need to state the factors, but this is not factorable, so I'm just going to multiply through by that one big factor. So this can also be a factor. It doesn't have to be two different factors. We can just treat this as one big factor if we group this. So I end up with x squared minus, I'm going to write this in order, x squared plus 8x minus 9 is equal to 2x squared plus 6x minus 12. Okay, make it equal to 0. Subtract x from both sides. Subtract 8x from both sides. Add 9 to both sides. Okay, and I end up with x squared minus 2x minus 3. Now this is solvable by factoring. Okay, so I can factor. My factors don't conflict with any of my roots here. So I end up with x is equal to 3 and negative 1. So these are my two solutions for this particular equation. Okay, so there's lots going on here. Embedded fractions, so we need to understand how we get rid of these embedded fractions. We can multiply through by the denominator. Okay, we just have to make sure we balance the fraction when we do this and watch our algebra. We need to state our restrictions for here. Now, if we run into a quadratic that's not factorable, you are allowed to state the restriction as that not equal to 0. Multiply through the equation this time. Instead of balancing the fraction, we're balancing the equation. Multiply through by the denominator to clear out the denominator, and then we can combine our like terms and solve.